Hello, my name is Antti Pulkkinen, and I work at the Catholic University of America and NASA Goddard Space Flight Center's Space Weather Laboratory. And in this tutorial, I will discuss an example coronal mass ejection or CME analysis process using Integrated Space Weather Analysis System, ISWA. What I will do here, I will generate a flowchart that gives you an example a process for detecting and analyzing coronal mass ejection events, and then I will actually show you a real-life example of this process using the products that we have available through the ISWA system. Alright, so the first step that you need to carry out in setting up this process is, of course, you have to set up your ISWA displays. So set up your ISWA displays. This is the first necessary step to get you going. The next step we will identify here is now the first part of the actual circular process that we'll be generating here, and the first step in this is you need to identify if there are any significant moving objects in the ISWA displays that you set up. Significant moving objects in the ISWA display. Question mark. Okay. So this is the first step, really the first significant step in the process. And this question leads to two different branches in our process. Let's create here the yes branch, and then another branch which is the no branch. Okay. And let's put some text here too. So this is yes branch, and this is the no branch. And we will discuss the no branch a little bit more in detail first. So you have your displays up. You did not detect any significant moving objects in your displays, which leads you to the no branch. So the next step is that you can actually sit back and then relax a little bit. Relax for XX minutes. The XX is determined by the need for timeliness of detection of the CMEs, and also determined by me in terms of temporal cadence of the displays that you set up for these purposes. The chronograph imagery that I will be using later on in the actual example have typical cadences varying from 15 to 30 minutes. So for example, for my applications, the XX would be something in the range from 15 to 30 minutes or so. Okay. So, and then next step is once you have relaxed for a little while, then you refresh the displays. Refresh the displays. And let's make the part of flow here too. And once you have done that, you will go to the beginning of the process itself and identify if there are any significant moving objects in the ISWA display. Now, of course, this branch of the process operates as long as there are no significant moving objects in your ISWA displays. But of course, the actions change if you do indeed identify something significant moving in the ISWA displays that you have set up. And if this is the case, then the first step in the yes branch is you have to, or you should identify the spacecrafts that see the moving object. Okay. and once you have done that, then you can start to carry out a little bit more in detailed analysis. In the next step, you can identify, for example, what is the direction of the CME. So determine the direction, let's say propagation direction of the object. An object, of course, in our case, would typically be coronal mass ejection. Once you have done that, you will go to the final step in the yes branch, which is further actions. Just generally further actions. This could be, more detailed analysis, alerts, and so forth. Don't need to specify them here any further. Let's make this a little bit nicer arrow here. Oops. Okay. And okay, that's satisfactory. So, and then once you have carried out the further actions, for example, more detailed analysis of these moving objects or coronal mass ejections, and your alerts and so forth, you can return to the core part of the process by means of jumping to this part of the process. You refresh your displays and then go sort of to the beginning point of the process itself. And again, this starts to repeat itself if there are no further moving objects in the displays, and this goes along as long as there's nothing interesting in the displays. And once again you identify something of interest, you go to yes branch and then follow the further analysis that follow the identification of this object in the displays. All right. So, but how does this work in practice? And then to show this, let's go to integrated space with the analysis system. Let me clear the other displays. Let's build the whole display from scratch. So the first initial step in the analysis was to set up your ISWA displays, and let's do that here. So now that we are interested in coronal mass ejections, of course the primary instrumentation of your interest are coronagraphs. So let's bring in some coronograph data into these displays. Let's bring in, use the gallery tool for stereo A and B. Let's put the B above here. Bring stereo A little bit further down. And then, of course, we have coronograph imagery coming also from SOHO. So let's bring in the gallery tool also for SOHO here. And the gallery tool shows a sequence of latest images from each individual instrument. For the sake of completeness, let's bring in also individual frame displays here. First ASCO C3 and then let's bring in stereo B and then A also. What is interesting with these is that let's put behind there and stereo ahead here, is that you can play these things also in movie mode. So if you press the movie mode here, it brings in some of the latest frames into the imagery and then loops that for you. And here's essentially the same thing using the sequence of still imagery. So now we have set up our ISWA displays, and then we can go to the actual first step of the process. So we need to identify if there are any significant moving objects in the ISO displays that we just set up. Now, for purpose of demonstration, let's use the global date time functionality of the integrated space with analysis system, and let's go to September 22nd and pretend that we are living September 22nd right now. Well, actually, let's go to September 21st, and let's go to at 10:30 p.m. UT time, and update all the other displays to that time. So the first step was to identify if there are any significant moving objects in the imagery, and even though there seems to be something around here in the stereo A and B imagery, that is a very faint structure and really is not significant, and definitely is not a very signature of a strong CME. So in this case we would go to no branch of our process. Now we can relax for say for 15 minutes. So and let's pretend that we have relaxed for the other 15 minutes, and then we can move the time 15 minutes ahead to 10:45, and let's update the displays again. And again we can check if we see any significant moving objects in the displays. There is nothing really too significant in these displays, so we follow again. So there are nothing of interest, so we can relax again for another 15 minutes or so, and then we refresh displays. Let's go now for the purpose of demonstration a little bit further. Let's go to say 11:30, so we have repeated this cycle for a few times. And now, of course, the situation changes quite a bit. So now we can start to see that there is something significant in the all of the imagery. So we have moving object here in the stereo B imagery. We do have already an object, moving object, also in SOHO LASCO C3, and we do see also the same moving object in stereo A imagery, and then that conclusion is also confirmed by these movies in the bottom of our ISO displays. So what follows next? So we need to identify spacecraft that see the object. So we already did this. So all stereo behind, SOHO, and stereo ahead can see the object. The next step is to determine the propagation direction of the object. Okay, so how do we do that? For that purpose, let's go ahead and bring in information about the stereo location. So you can access this site if you Google where is stereo, and take the first link, and then we have a stereo orbit tool to go for this historical event. So we were looking at September 21st. So let's bring in the location of stereo September 21st. So here's the ecliptic plane. The stereo B location is here, stereo ahead is here, and the Earth is here. So planets and spacecraft are moving this direction in the ecliptic plane, and of course SOHO spacecraft is in this scale very close to the Earth. The SOHO Lagrange 1 point where SOHO is located is about 1/100th of distance between the Earth and the Sun from the Earth. So it's really close to the Earth in these scales. So in ISO displays, we see that the coronal mass ejection in SOHO imagery is going to the right, and in the stereo behind imagery the same CME is going to the left. So what can we say about the direction? So imaging from the Earth, we have something going to the right, and from the B we see something going to the left. So that gives an indication that the CME needs to be propagating this direction. If it's going to this direction, then you would see propagation towards the left from B and to the right from the other soul hole.